Suppose an annuity consists of semi-annual payments of $1,500 for a term of 8.5 years. Using a rate of 7% compounded quarterly, let's calculate both the present value and the future value of the annuity. Since the frequency of our payments and the frequency of our compounding are different, we are going to have to calculate I2 because this is a general kind of annuity. Let's take I1 as the rate that's given to us, which is 7% compounded quarterly. This means that F1 is 4, and we're hoping to have the compounding frequency match up with the semi-annual payments. So we're going to take F2 to be 2. Now in this case, I can simplify this power a bit just to make it easier to put into our calculator. Let's just turn that into a squared. So let's start with our open bracket, 1 plus 0.07 over 4. I'm going to close that bracket and square this number and then subtract 1. And now that we have this number, I do want to save this into memory, so I'm going to store this under number 9 so that I can use the recall number 9 feature to bring it back when we need it in the future. Assuming that our payments do happen at the end of the payment period, let's grab the present value formula for ordinary annuities, and let's start filling in some of the values that we know. So for example, we know we have a payment size of $1,500. Let's change I to I2. And then let's try to figure out the N value here for our power. So payments are semi-annual, which means the frequency is 2, and we need to do this over the span of 8.5 years. So 8.5 times 2 gives us negative 17 inside of that power. All right, we should be good to go now. So starting in the numerator of our fraction, 1 minus bracket 1 plus recall 9. Let's close that bracket, raise this to the power of negative 17. I'm going to hit the equals button here and then go ahead and divide by recall 9. Okay, once we have this value, we should be able to multiply by our payment size of 1,500 to obtain our present value. And we get a present value of $18,931.14. And we should be able to quickly move into part B of this question, calculating the future value. Let's take the 1,500 once more. We're going to change our i's into I2. We've already calculated n. We know that n is equal to 17. So beginning in our numerator, open bracket 1 plus, let's recall I2, close that bracket and raise this to the power of 17, and then subtract 1. I'm going to hit the equals button here and then divide by I2. Once we have this number, we should be okay to multiply by the payment size of $1,500. And this gives us a future value of $34,146.55.